In this question, since the options are in tanx and cotx form, and we know that the derivative of tanx and cotx is sec square x and minus of cosec square x respectively. So it gives the hint that we need to change the expression in sec square x and cosec square x. So we need to change it in such that we can take integration, we can integrate separately. So here it is 1 by sin square x cos square x dx. I can, since I know that sin square x plus cos square x is 1, so I can replace 1 with sin square x plus cos square x by sin square x cos square x dx. Now I can separate both the term, so it will be 1 by cos square x minus plus integration 1 by sin square x dx. So integration of sec square x dx plus integration of cosec square x dx. Now I know that integration of sec square x dx is tan x, and integration of cosec square x dx is minus of cot x, and since it is indefinite integration, so integration constant c will be there, so our answer will be B.